In today's session, we are going to see about subtraction of two 8-bit numbers using 8085. Subtraction of two 8-bit numbers using 8085 microprocessor. So 8085 microprocessor is an 8-bit processor, so it is used to subtract two 8-bit numbers. So let's see for the subtraction. I take two data here again as usual. So I have a data called FE, again FF. Let's take the highest 8-bit number always. Take the highest 8-bit number. And let's see for lower minus higher number. So this is a lower number and this is a higher number. So FF is the highest and before that is FE. So the FF decimal equivalent is, this is a hexa number, decimal equivalent is 255 and FE, so default it should be 254. So when you subtract 254 minus 255, the answer is magnitude is 1 and it should give a borrow also to be 1, which you called as a carry here. So the answer is 1 1. So you can't subtract 254. You can't subtract 255 from 254 because 255 is a larger number. So here what the solution will be? So the difference between 255 and 254 is 1. So that answer you'll be getting it. That is a subtracted value. And carry will be 1 because you have to borrow and then only have to subtract. Then only it is possible to subtract a larger number from a smaller number. So let's go for the subtraction process here. The same like addition. Here we have MVI. Let me consider A comma FE and I write MVI B comma FF. So as we did in addition in the same way, to go for subtraction we have to go for sub B. Sub B is nothing but A minus B. Since I'm going to subtract a smaller number from a larger number, I've used A to be FE and B to be FF. So sub B is A minus B, so FE minus FF it will do. Now, when you do the subtraction process, again here also it will check for carry. So carry is nothing but here it's a borrow flag. So to initialize a carry or a borrow register, we don't have a word called borrow, we use only carry even for borrow. So we initialize MVI C comma 00 as we did for addition. Now after subtraction, it has to check for the borrow flag. If it is 255 minus 254, it is very simple, you can directly store the result. But it is 254 minus 255. So some steps are there. Let's see what it is. So after subtraction, so you have initialized your carry register. That can be done in the beginning also. Even on the top you can write before MVI A comma FE, there also you can mention MVI C comma 00. It is an initialization for borrow register or a carry register. Now after subtraction, you have to check for carry. If there is no carry, go to the loop L1. So you can directly store the result, store the accumulator, it can subtract and store the result in some location 8200. That's okay. Because if it's 255 minus 254, then it is very simple. It can subtract and the answer will be 1, 1 will be stored in accumulator and there will not be any carry at all, there is no borrow required. But here it is 254 minus 255. So in this, we do perform 2's complement subtraction. So what we do here is, there is no carry, store the result. Otherwise, increment the carry. After incrementing, I have some steps. So I need some space here. So let me write this loop 1 with some space mentioned. So let me write a loop L1 down. Just I'm giving a space, nothing much. So this is when I write here L1. This is your STA8200. Because I won't introduce 2 more instructions in the middle, so I just kept it down. Now what you're doing, we are subtracting, checking for a carry. If there is no carry, store the result, otherwise increment the carry. And then there are 2 steps involved here. What we're supposed to do is, we need the result 0, 1, 0, 1. So what we do is, after subtraction, the result will be stored in accumulator. So what you do, you are complementing the accumulator and then adding 1 to it, since it's a 2's complement subtraction. So these steps tell about your 2's complement. I'll tell you why do we do this step. By doing a calculation, complement the accumulator and then add 1 to it and then store the accumulator content. As usual, now accumulator is free. If there is a carry, move carry to accumulator, then store the accumulator content, in A201 and then halt it. So this is the step. It's a very simple step. So what do? We take FE and then FF and then we subtract. After subtracting, we're checking for a carry. If it is 255 minus 254, there will not be any carry. So directly you can store the result L1. L1 says that. But if there is a carry, you have to increment the carry. If you want to increment the carry flag, first itself you should have initialized. That's the step which we have introduced in the middle, MBIC, 00. Increment the carry. And then we are performing 2 steps here to get the result, which is complement accumulator and add 1 to it. So you may have a doubt. It is similar to addition. You may have a doubt why we do this complement accumulator in ADI1. Let me do the model calculation for this. So if I do the calculation here, I hope you'll understand. We have taken FE and FF. So it is the process. This is your FE minus FF. So this is your subtrahend. This is your minuend. Data to be subtracted have to be taken always for performing 2's complement subtraction. So data to be subtracted is your minuend. It is 1, 1, 1, 1. Perform 1's complement for that. So it becomes 0, 0, 0, 0, 0, 0, 0, 0, 0. Performs 2's complement for that. So you add 1 to it. So it becomes 0, 0, 0, 0, 0, 0, 0, 0, 1. So this is your subtracted 2's complement answer. Okay. But the actual answer is, you need 1 as answer. You saw in the beginning itself. Here FE minus FF. So the magnitude is 1. So the answer is 1 here. And the borrow should be there, since it is 254 minus 255. So we are verifying this in the calculations. Now we got the step as, like here you can see 0, 1. So we have performed 2's complement. We have taken the minuend, we have taken 1's complement of it, 2's complement of it, and then the next step is you have to add with the subtrahend, which is FE. That is your FE is what? 0, 0, 1, 1, 1, 1. E is what? 0, 0, 1, 0. E is 14. So 1, 1, 1, 0. So this 0, 1 is added with FE. So 1, 1, 1, 1, 1, 1, 1, 1. So in 2's complement subtraction, we are getting the answer as FF. But When you do FF minus FE or FE minus FF, we have to get the magnitude or the value as 0, 1. The answer should be 1. But here we are getting FF. So here what we do, when we complement the accumulator, now this is stored in the accumulator. After subtraction, this is the result. After subtraction, this is the result. So in the accumulator, it is storing 1, 1, 1, 1, 1, 1, 1. So that is your FF. Now what I do, this is where after subtraction it stops. But my answer is 0, 1. I'm not getting any 0, 1 here. So what do I do? Now I'm complementing this FF. When I complementing it, so I do complement the accumulator, I get 0, 0, 0, 0, 0, 0, 0, 0. And then I'm adding 1 to it. I'm adding 1 to it. So 0, 0, 0, 0, 0, 0, 0, 0. So which the answer is 0, 1. When it is doing this process, it will check for the borrow flag or a carry. Any carry flag is set. 0 plus 0, 1 when I'm adding, no carry set. So here the carry for this is 0. There is no carry set at all when I add 0, 0, 0, 0, 0, 0, 0, 0 with 0, 0, 0, 0, 0, 0, 0, 0. Default the carry is 0. So when it is doing this operation in subtraction, it will check for the carry. If then it will complement the carry. It itself will complement the carry. So 0 becomes 1. So CMC is complementing carry. So now the answer is 0, 1. Carry is 0, 1. For example, if the carry has been 1, then the carry, when you complement the carry, then the carry will become 0. Now the carry is 0 here, so it itself is complementing the carry. So the answer is 1. So I'm getting the answer also to be 1, carry also to be 1. So I've got the answer to be 1 and carry also to be 1. So this is the 2's complement subtraction. So in order to get this result only, we add 2 steps here. Complement, accumulate in ADI1. And this step comes only when we have a smaller number going to subtract a larger number. So that is when you do a larger number subtracted from a smaller number. A larger number is subtracted from a smaller number, we have to perform these steps. Otherwise, it is not a matter. For example, we have 3, 3 minus 2 is 1. But when you perform 1 minus 3, you have to add these steps. Then only the result will come exactly. So 1 minus 3, when you do, the answer is 2. 3 minus 1 is also 2, but 1 minus 3 is 2 along with the borrow. So when it is performing like that, you have to introduce these 2 steps. That is what I have shown to get the result. You can also try in that way. This is the subtraction of two 8-bit numbers using 8085. I hope you all understood. Thank you.